When we are dealing with RF elements like antennas and amplifiers, we see that these amplifier and antenna gains are specified in terms of dB, and we usually see these scalings like dB, dBm, dBW, dBV, dBu, and dBsm in different scenarios. So in this video, let's explore what is meant by these type of specifications. So let's start with an example. Consider we have two scales in x and y axis, and we are observing some values in x axis. So these are the observations for y axis. Here you can see that there is a multiple of 10 which is happening along the y axis. So if we are plotting from 1 to 100, here you can see that from this graph itself, it is very easy to visualize and say what is the values which is happening at x2. So here we can see that at x2 the y value is 10, and x1 the y value is 1. But let's see what will happen if we increase the scaling of the y. So I'm increased the scaling of y from 1 to 10,000, and here you can see that now it is not easy to say what is the value of y at x equal to 2. Because of this increase in scaling, these smaller variations are not visible now on the scale. Let's see what will happen if we further increase the scaling. So now I have increased the scaling on y from 1 to 10,000, and here you can see that these smaller changes on the scale is not visible now. So now I am unable to say what is the value of y for x equal to 2, x equal to 3. That is not predictable to me because in graph that is not clearly visible. So if we have a wider variation of the scaling, when we use the linear values, it is not possible to visualize, clearly visualize. Let's see what will happen if we convert that into the log scale. So this is the converted value in log scale. Here you can see that the scaling is happening only from 0 to 40. In linear scale, as it is changing from 1 to 10,000, in dB scale it is happening only from 0 to 40 dB. So if we plot that, we will be able to easily visualize what are the variations in y. So if we convert that into this linear scale, we can easily say what is the value of y in linear scale also. That is the advantage of using this conversion from linear to dB. If you have a wider variation on some values, it is always better to convert that into dB and use that for plotting. So it will be easy to visualize. That is the main advantage of saying these values in dB. So let's see what is meant by dB. So this means that dB means decibel. So deci means it is the unit which is usually used to specify the sound waves, and this bell came from the scientist named Alexander Graham Bell. So let's see what are the equations used for converting from linear to dB scale. So actually this dB is not like a unit like meters, centimeters, or nothing like that. So it is a relative scaling unit. Let's consider if we have two persons, and if we are saying this person is taller than this person, then we are saying their relative height. So likewise, this dB is a relative measure. Here we will be usually comparing, so we will be usually comparing output power with respect to input power, or we are comparing some power with respect to a reference unit, similar to as we are comparing height of this person with respect to this person. So this is a relative unit, not like not unit, this is a relative scale. So dB always refers to a relative measure. So this is the conversion for the power from linear to the dB. Here you can see that for converting to the dB, we have to use the equation 10 log 10 of P out by P in. or 10 log 10 of P by P reference. So if you have to convert that voltage level to the dB, you have to use dB is equal to 20 log 10 of V out by V in, or 20 log 10 of V by V reference. Here why we are using 20 is we know that P is proportional to V square. That's why we are using 20. So these are the two main equations we are using for the conversion. This you have to always remember while you are dealing with dB. We saw that dB is a relative unit. So if we specify like dBm, dBw, dBsm, dBu and dBv, these will become the absolute units because we will always be specifying the reference values, and based on that the values will be calculated, and these will be the absolute scaling. So these uh, letters after dB actually specifies what is the reference values that we are using to calculate these values. So in case of M, it specifies the milliwatt, and W specifies the watt, SM specifies the square meter, V specifies the voltage, and U specifies the unloaded voltage. So these values actually specifies which reference that we are used to calculate the dB. So let's see what is mean by dBW. In case of W, it specifies how the dB is calculated and what is the reference value. The reference value that we are calculating here is 1 watt. That is, we are using 1 watt as the P reference. So this will be our equation. P in dBW equal to 10 log 10 of P by 1 watt. So let's see what will happen if we are specifying some watt for the this input power. So let's say if P is equal to 1 watt, if we substitute 1 watt, we can see that it will become 1 by 1 and log 1 is equal to 0. So the power in dB will be 0 dB. If it is 10 watt, it will become log 10. Log 10 is 1, that becomes 10. So if it is 10 watt, that will be 10 dB. dBW is used commonly in high power audio amplifiers, radio transmitters, and satellite communication systems. So these are the two equations for dBW to linear conversion and vice versa. So if you want to convert from linear to dBs, you have to use this value, this equation P of dBW equal to 10 log 10 of P by 1 W. And if you want to convert that into the linear scale, it will be like this P by 10 and then 10 to the power of P by 10. That is this equation 10 to the power of P dBW by 10. So this is the two equation that we have to consider while considering dBW and linear scale. Next is dBm or dBmW. Here the decibel relative to 1 milliwatt. The power is specified in 1 milliwatt, and this is the equation where P of decibel with respect to milliwatt equal to 10 log 10 of P by 1 milliwatt. So this will give rise to dBm value. So if you want to convert 1 milliwatt power into dBm scale, we can substitute 1 milliwatt here and it will become log 10 of 1 and it will become 0. Then P dBm will be equal to 0. If we want to convert 1 watt, substitute 1 watt here, and here you can see that it will become 1 by 1 into 10 to the power of minus 3. So this will become 10 log 10 of 10 to the power of 3. So that gives 30 dBm. 1 watt corresponds to 30 dBm. And it is mainly used to specify low power signals like Wi-Fi, Bluetooth, and cellular signals, as it is specified with respect to the milliwatt power. These are the two equations. If you want to convert linear to dB, you can use 10 log 10 of P by 1 milliwatt, and if for the reverse conversion, that is P of milliwatt equal to 10 to the power of P of dBm by 10, you can use these two equations. If you want to convert from dBW to dBmW or vice versa, you can use this equation, because the only difference between these two are the reference value. In dBW, we are using 1 watt as the reference, and in dBm, we are using 1 milliwatt as the reference. So, this can be used for the conversion. To convert into dBm, you can just add 30 to the dBW value. So this is some examples. If you want to convert 1 watt, we know that 1 watt is 0 dBW. That will be equivalent to 30 dBm. Next is dBsm. So this is decibel relative to 1 square meter. So this is the unit of radar cross section. We know that radar cross section is a measure of power scattered in a given direction when the target is illuminated by an incident wave. Sorry. So this is the equation for the radar cross section. Sigma specifies the radar cross section. So the dBsm scaling specifies 10 log 10 of sigma in meter square divided by 1 meter square. So the reference is 1 square meter square is taken. So this scaling is known as decibel square meter. So these are some of the common examples. If it is like 0 dBsm, that means that the object reflects as much as radar energy as the 1 square meter metal sphere, because we are using 1 square meter as the reference. If it is minus 30 dBsm, so minus 30 corresponds to 1 by 1000. So the object reflects 1 by 1000 of 1 square meter metal sphere energy. Next is dBV. So here the reference is uh, 1 volt, and this is for the voltage conversion. If it is voltage conversion, we have to use 20 log 10 of V by V reference, and V reference is 1 volt. So this equation become V of dBV equal to 20 log 10 of V by 1 volt. So these are the two equations if you want to convert from dB to linear and linear to dB scaling. So one of the differences, because as we are using 20 here, to convert from dB to linear scale, we have to divide that value by 20 and then have to take 10 to the power of that value. Next one is dBu. This one specifies decibels unloaded, and here the reference value is 0.775 volt RMS value. RMS value means root mean square value. So it is mainly used in audio systems like mixers, outboard gears, etc. So this is the equations to calculate the dBu 20 log 10 of V by 0.775. So let's see why we are using this as the reference here and why it is known as decibel unloaded. Because in early days, the standard impedance for audio and telephone line was like 600 ohms, and actually engineers wanted to know how much voltage do we have to generate 1 milliwatt of power to a 600 ohm load. So by substituting 1 milliwatt of power and 600 ohm load, we get a voltage of 0.775. That is why we are using 0.775 here as the reference. That is, it is known as the unloaded decibel. So this is how we are calculating difference scaling. So this is some of the characteristics of decibel scaling. So here you can see that this is the linear scaling, this is the dB scaling. Here you can see that this is the 10 dB increment. So every 10 dB increment corresponds to 10 times increment here. So here 1 into 10, then 10 into 10, 100. Here you can see that these tenfold is corresponding to 0 plus 10, 10, 10 plus 10, 20. And these are some of the identities. So plus 3 dB correspond to twice the power, and minus the 3 dB correspond to half the power. And plus dB corresponds to 10, and 0 dB corresponds to 1. So these are some of the equations that we have discussed in this video. So I hope you get some idea about what it is mean by dBm, dBV, dBu, etc. If you find any of our videos useful, kindly support. Thank you.